Hey everybody, this is Larry. This is me doing an extra algo problem. Yeah, let's do one. And today we have an interval problem, which is kind of interesting because we just been doing intervals. 1124 longest well-performing interval. Hit the like button, hit the subscribe button, join me on Discord, leave a comment on the comments, and yeah, let's get started. We're given hours, a list of number of hours worked per day for a given employee. A day is considered a tiring day um, if and only if the number of days worked is strictly greater than 8. A well-performing interval is an interval of days for which the number of tiring days is strict. Okay. Uh, Tiring days is strict. Okay. So basically, this is just a sliding window one, right? Um, yeah. Now you have like, yeah. Um, also trying to think whether it can reduce to Cadane's algorithm, because you can maybe just do it like one and negative ones, and then now, right? Maybe. I don't know. I'm gonna try it. I think you can reduce this to Cadane's by just converting hours to one for well performing and negative one for not well performing, and then because anytime you get 0, you reset anyway, right? So yeah. All right, let's try that. I think it could work, but I could be wrong, to be honest. So yeah, so current is equal to 0 for x in hours. If x is greater than, let's just call it, oops, delta is equal to -1. If it's, we set to 1, and then we just current delta. Maybe we have like a count is equal to 0, right? So count increment by 1, maybe. If current is greater than or equal to 1, then maybe best is equal to max of best of count, else current is equal to 0 and count is equal to 0, right? Something like that, right? And this is Cadane's, but how did I get 7? So 2, 0, I mean, it goes to 0. Oh, I don't, oh, not positive, sorry, I got confused. Strictly less greater than 8. Yeah. Alright, yeah, I don't know why. I mean, I wrote 0 because I think I was just thinking about positives and not really, yeah. Alright, let's also try the second one, but that one should be pretty straightforward. We'll just be negative. Let's give it submit. So I'm not gonna lie. My full disclosure before I hit the submit button is I'm not super confident about this, but YOLO. Oh no. Oh, okay. Yeah. That makes sense. I mean, I just wanted to YOLO this because I thought it would be a cool idea if it's true, but I didn't realize that. I think I misread. I mean, okay, yeah. I mean, it's gonna be sliding window, but I think I misunderstood it a little bit, even though, or like I made a misinference, right? Like I inferred that you have to be like, yeah, but I guess that's not true because of stuff like this. Huh. I have to think about this a little bit actually, because even with sliding windows, I have to be careful actually, right? Is it sliding windows? Can you do sliding windows? It may be just like more algorithmic, or like maybe you have to like do some merge intervals things, right? Huh. That's a weird one then, right? Because in this case, you have to like you can't really do a sliding window greedily. All right. That is harder than I expected. All right. I mean, it's still gonna be binary, so it doesn't matter. All right. I mean, I guess we could do prefix sum and binary search. Can we? Yeah, I guess so. Wait, can yeah? No, you can't do binary search, can you? Because you can. It can catch up in a way, but I think you can just do maths. It's not even binary search, but you have to do maths, which is kind of weird. But basically, you have these chunks, and you're trying to merge them, and you're able to merge adjacent chunks if the math works out so that you can. Even then, how would you do it necessarily? Like, is it a greedy thing? Would you always greed? I guess so, because by implication, you only merge intervals if you have more things than the space. So then you always at least. No, that's not true. Because you got like 5, and then you could choose between left and right, and maybe one of them will burn one thing, but it just gives you a longer thing, right? Huh. This is harder than I expected. At least in terms of proofs. Like there might be a. Oh man. I very much underestimated this problem. Alright, let me think about it a little bit. Alright, let's say we do a DP thing on the current number, kind of like what we had, but we want to go back to. Okay, so we have an extra one. Does that matter? Or do you do a binary search on the. So I'm just thinking about like, okay, let's say an interval has to end here. How far can we go back, right? I think that's like how I would answer if there's a way to do it that way. But man, maybe this is a tiring day for me. Basically, you have just ones and negative ones. I guess I should put in the other case. But they used to be easy. Just put in here. Didn't really. Oh, well, I don't have the code anymore. But how do I go backwards, or even just like merge things without like a DPE thing? I mean, like obviously you could do n squared even on the segments, but how could we do it without a DP thing? Wow, today is a day where I struggle on mediums, both this one and the daily problem, clearly. Binary search on the answer? Yeah, okay. I guess that's how I should have done it. Binary, okay, fine. Maybe today I'm just a little bit slow. Yeah, we could do a binary search on the answer and then see if it's possible. Yeah, because I know that I said binary search before, but I think that was from the perspective of, okay, I start here. How far do we go, and we can binary search on that, which I don't think is true because you can't. It's discontinuous like it's not monotonic, but I guess we can binary search on the length, which should be good. Okay, fine. Yeah. Okay. I'm very slow today. Luckily, this is not a contest. Yeah, okay, fine. Right. This is regular binary search. not going over binary search today. Hope you understand. The other video was half an hour, and this one 10 minutes just doing silly things, right? All right, so let's just say there does exist one that is mid, then that means that mid is a possible answer, and we're going to try a bigger interval. So we said left is equal to mid, and then else right is equal to mid minus 1. This means that this has to be this, and then we can just return left, right? Okay, and then now basically we want to say there exists an interval of length target, right? And we could actually have done the prefix. I guess doesn't. I mean, sliding windows no matter what, but we could have done. I guess prefix some. I don't know if that's easier, but yeah. All right. So then now, right, count is equal to 0, right? Total is equal to 0. So for I in range of n, if our sub I is greater than 8, then which one is count? Which one is total? I forget. Okay, right? Yeah. And then now, if I is greater than or equal to target, then that means that target minus 1, then that means that we have a full length. So then yeah, if count is greater than 0, we return true. That means it exists, right? That means that yeah, okay. And then the other thing we want to do is if I minus target is greater than 0, then we subtract out the other, yeah. Oops. Maybe I could abstract this part actually. Basically, this is just a sliding window part sliding out the other side. And then if we don't find one, then we return false. Yeah, I mean, I think as soon as I came up with it, I knew this would be right, but well, I may implement it well. Oh, I did implement it well, I guess. But yeah, the idea should be right. I'm just having a rough take, really. But why is that returning 0? So 1. Does this not try 1? 1, do I have an off by 1? I probably have an off by 1. I minus target, target is 1. That's weird. So did I do the wrong thing? Maybe. What is the input called? Hours. Just making sure that I'm looking at the right thing. 2 is false. That's true. 1 is false. Okay. Oh, of course. I have to slide out first, and then I have to check. If you don't slide out, of course, that's just a silly mistake. I'm so not good today. Of course. Oh, what? Do I have an off by 1 again? Oh, how am I so bad today? On binary search, I don't know how binary search went. All right, 969, 2 is 4. Oh, I was wrong on binary search. Okay, because 2 is false, but 3 is true. Huh. That is awkward. I'm trying to think. So right now I'm thinking, do we, like, even numbers don't make sense because even numbers can be 0 and then no, but that doesn't even matter because you could catch up, right? So if you have I'm just being dumb. So this is wrong then. I was very wrong about it being right. But then basically you have like 1 1. I'm just going yeah, 1 1 negative 1 negative 1. Like in this case, like yeah, maybe eventually you could catch up. But and you know, maybe you add more negative 1 to the middle so that you cannot do like 2 or something or 3 or whatever it is. But so you can add like random junk, but it may just be forced in the middle. Huh. Wow, I am just like really bad today. Alright. Scrap this. How did I think? Some days you're just really off. Huh. 2 wrong solutions. The first one I was just like a little bit YOLO. I thought I maybe spotted a cool solution. The second one I'm just really bad today. Wow, I was convinced that I was right. So I don't know what happened here. But okay. And I'm not gonna lie. I think some of the struggle is that I kind of want to use the bathroom, but I do want to solve this first. This is a medium. So it's not binary search because it's okay. Can get some water, even though I need to use the restroom, but I'm also thirsty. So I'm just double checking my blood sugar level. I'm not usually on the phone, but I have my blood sugar thing, and I'm trying to make sure that I'm still in good range. So it is true that having 3 does not mean that the 4 is over. Honestly, I think I'm stuck on this one a little bit. It's 1 negative 1. And we can't greedily remove stuff because you saw that some of the cases it doesn't even make sense. Like, you know, you need the beginning. Well, not that one, but this one you need the beginning. So you can't even chop. And we just do merge intervals. But I don't think that necessarily gives you the optimal move. Huh. Sorry, friends. I am. Oh, I got the water evaporator. I'm just stunned, to be honest. Because everything else just requires proofs. So I don't even know that, like, if I did some greedy thing. And it's not clear to me that, like, you always want to add. Is there value in adding the? Because it does make it longer, but. Okay, so for example, this one is going to be 2, 4, 1. It'll be encoded that way. So then how do we combine this? I mean, I know that we can do some greedy things and stuff, but I feel like there's a case in which like have to make decisions about merging, and I can't really do that well. Oh my god. Longest path in the DAG is there like a DP thing? No, but that's n square. That's too slow. And also, if you have it that way, then you just do it n square. But is there? I don't even. I'm trying to think of some property that we can figure out so that I could exploit. But I don't even feel like I have one really. Maybe today is just not a good day for problem solving, but let's say we don't have any ideas. That's which is very weird for me, for medium anyway. Well, I guess I could use a hint. I'm not going to use a hint quite yet, but I feel like I'm just missing one thing, and today I'm just not seeing it. The 1, -1. Am I over-indexing on 1, -1? Is it enough to just connect? But then you could connect to the left and connect to the right, right? And also, if you iterate it that way, then it's going to be n squared, so that's not even that fast if you're not careful about it. Because my thing is that you could have like say 3 and 5 in the middle, and then this would connect. But then like if you have stuff to the left, you like how do you decide between this and like whatever it is, right? Like say I don't know, right? Like how do you decide where to go? Maybe the one to the left has more, right? Or you can't go left here, but yeah, you remember something like that maybe. And then now you have to figure out like if you're here, you're trying to go left or right, and it's unclear why you would choose left or right specifically, heuristically. Am I differently? How would I do it if I do something with prefix sum? Is there a prefix sum? I mean, it gets as complexity as bit. And not even okay. Okay, let's say we have prefix sum, right? And now we have this one, or maybe this one, something like this. And now you have -1, you have 0, and then you have 1. So how do you go from 1 to the prefix? Well, 1 from the prefix is by definition, so that's fine. But then let's say we have 666, right? And now you have to do -3 or -1, -2, -3, -2, -1, right? Then now you have to find the -2. But how do you decide which negative? I guess this -2 is fine. But then that doesn't, let's say this is a 9 then, right? or 99. Then now you have 1, 2, 1, 0, -1, 0, 1. Then now this 1 is going to look for the 0. How do you merge all of these together if that's the prefix, right? Unless I did the prefix wrong, which is possible. No, this should be right. Like, how do you go this 1 and match with this 2, or even this 1? This one matches this one is fine. Wait, is that true? How would that even work? I think technically it started with 0. I think that's how I messed up with this understanding. Okay, fine. So then this 1 goes to match this 0. But then what if there's another 9? Then now you have a 2, and you can match, I mean, you could match this with this 1, but you actually want to match it with this 0. So then now you have to do like a max element thing. Can I do that like a prefix min now? Maybe, but that and you can also just binary search to see the min of yeah, you could do a binary search on the prefix min. So you do a prefix sum, you do a min on the prefix sum, and binary search on it. Now, what am I saying? Okay, so let's say I have 2 here. How do I find the 0 instead of? So we find. Well, there should be a prefix thing, right? So this is kind of reminding me of LIS, maybe. Basically, because anytime you could use this 1, you could just use the 0, because 0 would be, in a greedy way, better, right? So if you go up, that's the case, right? What if you go down? I guess I had something like that before. And this, oh, and of course it starts at 0, I forget. But then, oh, and then, well, this -1 only goes to -2. So then when we go down, we find the earliest index of that. So that means that we have to keep track of the negative indexes. Does that work? That's a, let's try it. I don't know. Alright, fine. For I, X and enumerate hours, right? So what we want to say is, okay, so current is equal to 0. If X is greater than 8, else, okay. And then now, oh, not X, current. And now, if we reach, only if we reach negative, because by definition the first one's gonna be 0, right? So okay, so maybe we have a lookup or best or something, a hash table, and then basically if current is less than 0, if current not in best, because if it's in there, that means that we've seen it before, and we would just take the earlier one anyway. So then if current's not in best, then best of current is equal to I, and I'm gonna make sure that best of 0 is equal to 0 or something like this. I guess technically -1 for one index above, but that's a little bit awkward writing. We'll ignore that for now because I'm still just trying to fix it. Right? And then else, all right. But whether that's true or not, oh, and this is just the best array, but then we have like max answer or something, which is 0, right? And then basically, if current is greater than 0, then we just do max of this and best of 0, which is -1, I suppose. And that's not true. This is I minus this for the number of things, right? Because we just take the entire prefix. Otherwise, if it's 0 or less, then we want this to be minus best of current -1 if current -1 isn't best, right? I usually my head is like not really right today, but it looks okay. Let's give it a submit. I guess I just have to rethink everything, but that's a hard problem. Like I feel like, and I'm gonna clean this up a little bit. I just don't like the railroad names, but I did have this idea early on, but I didn't really follow all the way through and kind of went through the cases. I guess one lesson to to learn here for me is sometimes, and this happens to me sometimes, like not uncommonly, but also not frequently. So that's why I sometimes have trouble learning it, which is that I think sometimes I get a little bit, and I don't know how much of this, to be honest, is me just like streaming this, right? I don't have my pencil and paper ready, for example, but like if I was in an actual contest that I'm trying to do like 100%, a lot of the times I do actually just scribble on paper, but on stream I'm like, oh, maybe I could just do it in my head and kind of think it through. But this one I didn't think it through, I guess, with this direction. But I mean, I did. I'm not gonna lie, I actually do like the solution. I'm gonna just kind of rename these to be more consistent to be how I have it. I usually have it, but because it was annoying me. And this is like the last scene, right? This is a hard. I mean, I don't know if it's a hard problem, but definitely I struggle a little bit with it. But I also didn't think. I don't know. Maybe it's the mediumness, and I just kind of underestimated this problem. I didn't think I needed to use this dynamic programming thing. I thought that there was a more intuitive way of doing it, but or like it's more straightforward. But yeah, but basically the idea here is prefix sum. -1, you're trying to. I mean, I didn't do it. I didn't do it in a way that was just me explaining, but I think I was doing it in a way such that I was explaining to myself. So hopefully that kind of gave you an idea. But the idea here is that okay, you have a prefix sum with +1 and -1. So and you're trying to get the longest, right? So any number, because the 0 array is good, like the no array has the 0 element in the front. So any number that is greater than 0, you just want to take the entire prefix, because by definition, the delta, like for example, this 2 minus 0 means that we have two more busy hours or whatever they call it than not busy hours, right? This is regular prefix sum stuff. I'm not gonna go over prefix sum. We've been doing prefix sum all week. So I just watched my last couple of videos from the week, but yeah. So then, if any positive number, you just take the 0, and then this is why I came up with the case of okay, if you have negative, then you want to get the one that is in a greedy kind of way because of you could call it continuous or whatever. Was it discrete value theorem or whatever? Basically, you have to go because you only subtract one at a time. You can only go down in a step case kind of way, and coming from 0, that means that current -1 is going to be the earliest, right? If it's negative, then current -1 is going to be the earliest that you've seen it, because if you add 1 to that, then it's not bigger than it, and so you don't have enough of a thing. So current minus, and we just keep track of the earliest we've seen it. Yeah, and if you have smaller numbers, it goes later because this is always going to be decreasing in that way. And I did kind of made a little bit of a reference to longest increasing subsequence, and that kind of ties into it a little bit as well, in the sense that you have that because if you look at this array, or I mean, it's not really an array because I put it in a hash table, but because it goes -1. But if you kind of look at it as an array, it actually is an increasing function, right? I mean, because it's an index, because this stores the index, but it is an increasing function similar to longest increasing subsequence. So yeah, it's a kind of hard problem. Wow, let's take a look at some discussions real quick. 996. I didn't even get that reference because I was just there. All right, Lee, what do you got? All right, so Lee basically had the same idea I did. All right, that's pretty good. But I feel like that's so. Oh, and yeah, and this is the visualization that I was saying, kind of, but I didn't draw it out. Yeah, okay. Longest WPI was WPI. Oh, well, okay, fine. To be honest, I didn't. I think I just underestimated this problem. Underestimated. I'm George Bush, but I just underestimated this problem. I didn't think I needed to use this. Like, I kind of saw it, but I didn't follow it through because I thought there'll be a easier solution. So that's just on me. But yeah. Anyway, that's all I have with this one. Let me know what you think. And yeah, I like this one. I mean, I kind of think I learned something a little bit. But I don't know. That's what I have for today, though. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.